Hello, we're going to continue our next revision on metals, and this is on rusting. Rusting is essentially a word that we can only use on iron, because when iron reacts with two things, which is oxygen and water, what we get is hydrated iron trioxide. And hydrated iron trioxide is essentially our rust. Okay, so without further ado, let's dive into this 12-mark questions. So, first question here, simple questions about iron. One problem is that iron rust. Name two substances that iron react when it rusts. So in order for rusting to take place, you need water and oxygen. However, there are some students who will wrongly suggest carbon dioxide. That's wrong. Okay, oxygen and water again are the two essential conditions for rusting to take place. State the type of reaction when iron rusts. When iron rusts, it is essentially oxidation. For those of you who can be extended to appreciate a slightly deeper concept, when iron react with oxygen and water, what we get here is hydrated iron trioxide with H2O. The balancing would be a little bit different, but from your usual things that you are learning, but it is never tested, okay? But here we have, this is our rust, which is hydrated iron trioxide. Okay, so that is oxidation because we start off with iron and at the end of the day, the iron becomes iron oxide. Okay, so that's oxidation, which is essentially gain of oxygen. Oxidation is gain of oxygen. All right, moving on. Iron can be prevented from rusting by painting or coating with zinc. Now this question, B part 1, is actually focusing on painting. Okay, now so some students misread the question. So one of the things that you can do for yourself, an exam skill or a little trick that you can do for yourself is just to underline. Don't use a highlighter, you may just zip into the next page, but underlining just help you focus on the keyword, especially for those of you like me. My mind's all over the place sometimes because of I suspect I've ADHD. Yeah, so to help me focus, I underline things. Okay, so the first thing is, because this is a 2-mark question. Oops, I'm going to go back to that question. Sorry, it's over here. Yeah, so this is a 2-mark question. So with 2 marks, you need to have 2 points. Whenever you see the word explain, think about the why. Okay, so we want to paint, or even if you put a layer of grease or you put a layer of plastic over it, this is essentially our barrel or a layer method. This is a better word. Okay, it provides a barrel. Okay, and why is this barrel important? Why is this barrel important? That's our second point, because it prevents oxygen and water from reacting with the iron. Okay, so this is the method inside. So why are some students not getting the full marks here is because they did not mention what is the concept or what's the main idea of painting. Okay, so the painting here is to act as a barrel, and what are we trying to prevent the metal from reacting? It is oxygen and water. So 2 marks over there. Again, these are the things to take note of. A lot of students misread this question and they focus on zinc, but this question essentially asks for painting. Okay, so underlining might help you focus on the keywords. Next is we're looking at a process that coats iron with zinc. This is a very specific name, so you need to get this right. There's no other alternative answer. The word we use is galvanizing. So you can have a piece of iron over here, and when you coat it with zinc, this process is galvanizing. Okay, some students, one of the most common misconception or wrong answer I always see in this kind of situation is student put sacrificial protection, and it won't get you any marks here because it's too generic. Okay, here we are focusing on zinc coated on iron, so it must be galvanizing. Very, very specific. All right, next one. Explain why a layer of zinc protects iron from rusting even if the layer of zinc is scratched. Okay, so here you need to explain, so you need to talk about the why. Again, 2 marks, so 2 points. First, if you already have memorized the reactivity series, which is my version is quite interesting, okay, but I'm not going to share with you until you share with me your version. Okay, and then we've got aluminium and then zinc, and then followed by iron. Okay, so zinc is above iron, so zinc is actually more reactive than iron. So using a reactivity series, it should be able to guide you into the positioning of the metal. So zinc is higher than iron, so zinc is more reactive. So what if it's more reactive than iron? It is the fact that zinc can oxidize more readily than iron. Now, if you find that the word oxidize is a bit hard for you to recall or explain, then here the alternative answer would be hence zinc can react more easily with oxygen than iron. Okay, you need to be able to show comparison in order to get your second mark. Okay, that means you need to be able to discuss that zinc has a higher ability to react with oxygen more readily than iron. So this is what I meant by comparing to get your second mark. Okay, so aluminium reacts with iron oxide. So this is the reaction. Okay, the equation is provided. You need to explain why this reaction shows the relative reactivity of aluminium and iron. So what's happening here? If I were to zoom out a little bit, you can see that aluminium, okay, eventually become aluminium oxide. And why is this possible? Is because aluminium has the ability to displace, the word is displace, iron 3 from the iron oxide. Okay, so how do we answer this question? Okay, it is aluminium is more reactive than iron, so aluminium can displace iron from Fe2O3. If you find that the naming is a little bit hard, you can actually use the formula, because the formula is also provided for you, so there's less chance of you writing wrong type of formula. Okay, if you find that there's too much name for you to write. Okay, so the things that you need to take note for this kind of question is you need to be very, very specific with the keywords. Okay, so the keyword here is displace or displacement. So you need to use the word displace. It would be wrong if you were to use the word aluminium snatch oxygen from iron. Yeah, so this would be wrong. Okay, so Al snatch oxygen from iron, it is not precise, it won't be considered a keyword. Okay, so use the word displacement or displace. Alright, finally, it's the last question. Explain which substance acts as an oxidizing agent in this reaction. So what exactly is an oxidizing agent here? Let's just take a moment. Oxidizing agent is one that oxidizes others but itself reduce. Okay, so in order to answer this question, first you must state which one is the oxidizing agent, and then you need to explain the why because of the word explain. Okay, so here the answer is iron 3 oxide. And how do I know it's iron 3 oxide? So I'm going to rewrite this equation. Al plus Fe2O3, it becomes Al2O3 plus Fe. Oh, sorry, forget to balance. Yeah, okay, so we're looking at itself, but oxidizes others but itself reduce. And what we mean by reduce is actually loss of oxygen. Okay, so which one of them has loose oxygen? So when it comes to this kind of question, you need to be able to see the equation from this perspective. Before the arrow, they are the reactant, and after the arrow, they are the product. Okay, when it comes to identifying which one is the oxidizing agent or reducing agent, we are only looking at the reactant part. So it's either aluminium or iron 3 oxide. Okay, so it is just one of them. So you have a 50% chance of getting it right. Next, you need to know that at the end of the day, this substance is being reduced. That means it's losing oxygen. So the one that's being reduced is actually our iron 3 oxide, because eventually it has no more oxygen, right? So this is known as reduction. So by identifying it that Fe2O3 is the oxidizing agent, you would have gotten 1 mark here. Okay, then you need to explain why is it the oxidizing agent. It's because you can use the word donate oxygen to aluminium. You could use the word it takes electron from aluminium, although some of you will find this really, really hard to see unless you write out the half equation. Or you could simply say that it causes aluminium to be oxidized, because aluminium, if you can take a look here, aluminium gain oxygen and it becomes Al2O3. Okay, what I will write as an alternative is iron 3 oxide loses oxygen to become Fe. That would definitely get you the marks as well. Okay, so this is oxidizing and reducing kind of question. It all falls under the topic of redox. This kind of makes me want to dive into another topic, which is redox, because from that topic I would like to introduce the idea of half equation, and that was actually one of the last thing I've done with my students before I left school. And it was quite empowering because a lot of them got it within one period, and that's really not an easy concept to appreciate at iGCSE level. So maybe after this chapter of metals, I'll look into redox and then writing of half equation. If you think that would be useful for you after watching this video, maybe you can just drop me a DM, you could like, you could comment, you can subscribe, and let me know that if that is going to be useful for you, I will prioritize that section or that topic in my next video. Alright, see you around.